This video is to support the third year and National 4 engineering science course for the Analogue electronics booklet, and we're looking at how to ascertain what a resistor value is when looking at a resistor, which ties into task 3 of our booklet. So right here we've got a resistor. It's a very small electronic component. The purpose of it is to control the flow of current in an electronic circuit, and specifically to slow down the flow of electricity. Essentially the way it would work is that at each end of the resistor there's two wire legs, and each end of the wire legs would be connected to some other components or some other wires in the circuit so that it can create part of the circuit. What is really important to note, which isn't very easy to see in this video here, but there are 4 different colour bands on the resistor, and those colour bands give us a code that we can break so that we can decipher what the resistor value actually is. The last colour band in this one is gold, which is in relation to the tolerance of the resistor value, and that essentially means how much bigger or smaller that the resistor value might actually be compared to what it was intended to be, and that's there because it's very, very difficult and expensive to manufacture resistors that are of an absolutely precise value. However, for what we're doing, we don't need to worry about that 4th colour band, but the first 3 colour bands we are interested in using to decipher. So I've got 4 examples here on my piece of paper. The first one is to show you how we would value a resistor that has got a value of less than 1000 ohms. Our 3 colour bands in this case are orange, orange and brown. Now we can use the resistor value chart so that we can puzzle out these numbers. So for the first band is orange, and in band number 1 that's got a value of 3. The second colour is orange, which in the second band has also got a value of 3. And then the third band, which is brown, if we look at the column for band 3, it's got a value of times 10. Now what that means is that if we take the 2 3's together and read them as 2 3's together, then that's 33. And we multiply the 33 by 10, and if we do 33 by 10 we get 330, and the resistor value is 330 ohms. And this is how we would normally write the numbers in engineering science, but in the real world, if you were to try to buy one of these resistors, you wouldn't ask for a 330 ohm resistor. We would use a slightly different way of representing that value, which is 330R. So this is real world, but the top value is the value that we would normally use in engineering science. Moving on to the next resistor value here, this is for values of multiples of 1000, which is greater than 1000 or less than 1,000,000. Our values here, first band is brown, so again we can use our chart. Here's brown as the colour, and band 1 is the number 1. Band 2 is black, which we can see from the chart is 0. And band 3 is orange, which has got a multiplier of times 1k, 1k equaling 1000. So the 1 and 0 are read together, and we multiply that 10 by 1000, which will give us a value of 10,000 ohms. And again, in the real world, well, this is a perfect number for engineering science. In the real world, if you were to try to buy one of these resistors, you would have to ask for a 10k resistor. Next example is for the same kind of value range again as what the second example was, but this time we're using multiples of 100. In other words, our multiples are much smaller. And our band colours this time, for band 1 is yellow, so if I use my chart here I can see that band 1 at yellow has a value of 4. Band 2 is violet, which in the chart has got a value of 7. And then the third band is red, which has a value for band 3 of times 100. So we read the 4 and 7 together, 47 times 100, 47 times 100 is 4,700 ohms. And again, perfectly acceptable answer for engineering science. However, in the real world, You wouldn't ask for a 4700 ohm resistor. You would ask instead for a 4K7 resistor. And effectively what happens here is the K becomes a decimal point for this value, but because it's in thousands, then it becomes 4.7 K. 4.7 times 1000 is 4700. The last example is for a resistor value of over 1,000,000, and effectively it works in the same way as what it does for between 1,000 and 1,000,000, only instead of using K, we use the letter M for 1,000,000. It works like this. Our first value is blue, so if I find blue in my chart, then for band 1 that's got a value of 6. Second band is grey, which if I look in my chart for grey, band 2 is a value of 8. And then green for band 3 has a value of multiplied by 100k or 100,000. If I take my two numbers 6 and 8 together, multiply them by 100,000, that's got 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. That's 6,800,000. Now, similar to using K's in examples 2 and 3, I can use M for that, but it's 6.8 million, so it would be 6M8. 6.8 million. So again, in engineering science, that value is perfect. In the real world, if you're looking for a resistor with a resistance of 6,800,000 ohms, you would actually ask for a 6M8. So, with that, we can read through the example here in our page in the booklet, and then task 3, we've got 3 jobs to do. The first one is to colour in these 3 bands with colour pencils so that we could see what these resistors would actually look like. In task 2, we've got a table with a number of resistor values, and we're charged with using the chart here to find out what each of the colour bands would be to show us each of these values. And then in part number 3, we're working the opposite way around in our table here, where we're given the colour bands and we're using our chart to write down what the resistor value would be.